In my next example, I want to graph a hyperbola that is already written in standard form. The first thing I'll do is identify the center. So in our equation, we have x minus 3, y plus 1. That tells us that our center has to be located at 3, 1. Next, what I'm going to begin doing is creating the asymptote box. Now, there's a lot of similarities here when sketching the hyperbola and between this and the ellipse. Since the 9 is under the x term, x, as we know, go right and left. So we're going to go to the right 3 and to the left 3. Those will be our vertices. Vertices always come from the part of a positive term in a hyperbola. Okay, next, covertices. We have 16 under the y, so we'll go up 4 and down 4. So 1, 2, 3, 4. Covertice. And then we'll go down 4. 1, 2. Covertice. The next thing I'm going to sketch in is what we're going to call the asymptote box. It just serves as a guide to help me get a more accurate sketch. So we'll start at the vertice, go up till we're equal with the covertice through the other vertice. So our asymptote box is sketched. Now our actual asymptotes, those go through the diagonals of the box. So what I'm going to sketch here are diagonals. Goes right through the center every single time. Oh, man. Right through the center. Okay. So now that we have our asymptotes, which aren't very accurately sketched, we'll draw the actual graph. Graph starts from the vertices and goes out to the asymptotes. So what you see in blue is our actual hyperbola graph. The last thing I need to be able to do with the hyperbola is find the foci. To find the foci, we're going to use our numbers underneath our variables, 9 and 16. For a hyperbola, formula is a squared plus b squared equals c squared. So we see our value of c is plus or minus 5. Everything's based off the center. So we're going to go from the center to the right 5. Foci, and then from the center to the left 5, we have our second foci.